go ahead and introduce yourself.
So my name is Ernesto Pasco. I teach at IS 52 in Manhattan, and I've been teaching mathematics for quite some time now. This year I'm teaching the eighth grade curriculum. Can we?
Yeah, go ahead.
I'm teaching the eighth grade Common Core curriculum.
Perfect. All right, so I'm going to come inside of here. Okay, so yeah, just like you did, anytime you... The first question is, how does this lesson connect to and build on students' prior skills and knowledge, what was taught before the lesson, and what will come after it?
Okay. So we started this unit about 2 weeks ago, right after the state test. So this unit is all about the Pythagorean theorem, the big ideas of which are real numbers and the Pythagorean theorem. So the class started learning about basically finding the area of irregular shapes and then finding the length of a segment on a coordinate grid using what they know about finding the area of a square. And then that the topics, those lessons lead up to this lesson today, which is basically a geometric proof of the Pythagorean theorem. So our most recent topic was on discovering the Pythagorean theorem, where my students explored the relationship among the areas of squares drawn on the sides of different triangles, acute triangles, obtuse triangles, and right triangles, and asked them to observe a relationship among those areas. If they, like, I asked them to make a conjecture about the relationship among the areas of those squares drawn on the sides. And of course, they noticed that the areas of the squares drawn on the sides of a right triangle have a very special relationship. They did not find the same relationship among the squares that are drawn on other types of triangles. So then we build on that conjecture to prove geometrically the Pythagorean theorem, which is what our lesson today is. And our next lesson will be on we will summarize our lesson today, make sure that they understand symbolically what they just proved today, which is that the squares of the sum of the squares of the legs of any right triangle is equal to the square of the hypotenuse. So we will summarize that, and then we'll start with applications, finding the unknown sides of finding an unknown side of a right triangle.
Good. Talk about the standards or cluster targeted in this lesson. What did you do? So I'm recording. So talk about the standards or cluster targeted in this lesson. What did you do to make the lesson reflect the full intent of that standard?
Okay, so the focus standard for this lesson is G6, which is that students will be able to explain a proof of the Pythagorean theorem. And so based on that standard, the standard is very conceptual in nature. The kids have to be able to basically develop this idea of the Pythagorean theorem, this idea of that the sides of a right triangle have a specific relationship that does not apply to any other types of triangle. So I made sure that it's a student-centered lesson, that the students are allowed to explore, and in this lesson they were putting puzzle pieces together to prove that the areas of the sum of the areas of the two squares that are drawn on the legs of the right triangle is basically equal to the area of the square that's drawn on the hypotenuse.
Which of the core action indicators do you think this lesson best exemplified?
I believe conceptual understanding, because again, it's student-centered. My role basically was I was a facilitator, that of a facilitator. Just make sure that they have, I help them understand the mathematical facts involved in the lesson, which, for example, that the two frames of equal areas, the triangles of equal areas. So basically just guiding them through the activity and help them develop the idea the idea by themselves.
Discuss how this lesson illustrated the shifts required by the CCSS.
Well, let's talk about focus. The lesson is very focused on the Pythagorean theorem, although it also addresses, it addresses a foundational standard which was addressed in the 7th grade, but in terms of focus, it's geometry. In terms of coherence, it builds on their understanding of areas and the relationship among figures that have the same areas, no matter how they're drawn. And in terms of rigor, well, again, this lesson is very conceptual in nature. In terms of procedural fluency, eventually they'll apply the theorem that they just proved to solve real world and even mathematical problems. And in terms of application, well, that will be our next step, which is to apply this theorem to solve real world problems.
How did the students handle this lesson? Did they understand the mathematics of the lesson?
I believe so. Well, I would speak for most of my students because I've observed that some of them, there are 2 or 3 in a group who are really struggling, but I would say 80% of the students grasp the mathematical idea, which is that of the relationship among the sides of a right triangle.
How did you differentiate in this lesson? Did all students have the opportunity to work on grade level content?
Well, in terms of them being able to work on the grade level content, I would say absolutely yes. In terms of differentiation, during the Explore, we basically, the questions were scaffolded. Students addressed the first part of the activity, and I made sure that they were able to establish the relationship among the side lengths of the square pieces and the side lengths of a right triangle, one of those triangle pieces. And then we built on that. So my role was to pose clarifying questions. My role, I made sure that I did not redirect their thinking to my line of thinking, but rather ask clarifying questions, and made sure that they're able to appreciate the mistakes that they've made and the initial misunderstandings that they've had, and guide them through the entire process. So I did not rush them through the activity. At the same time, I tried as much as possible to make clear to my kids that, it's okay to struggle. This is a big idea. This idea about this Pythagorean theorem idea. So the lesson, I don't think they felt like the lesson was forced on them. So they process the mathematical ideas at their own pace.
Which behaviors from fraction 3 did the students best exemplify?
I'm sorry, so what is that again?
Which of the actions from core action 3 did the students best exemplify?
What is that? I forgot.
You want to move on?
Action 3. Oh, that has to do with mathematical practices. Because, well, solving problems and persevere. I'm sorry, I forgot. So solving problems and persevere in really solving them, if that makes sense. Constructing a viable argument and critiquing the reasoning of others. I give them an opportunity to make sure that they process what their classmate is saying and comment on it. In terms of using the appropriate tools, they use the puzzle pieces appropriately to make sense of the mathematics. But I think it's really more on the construction of arguments, because they were trying to make a generalization out of based on the relationship among the areas of those squares. So they construct viable arguments. They were able to support their statements, and the rest of the class is able to offer their comments, those statements.
Reflecting on the lesson, what worked well and what might you do differently?
Well, I think what worked well was the fact that they were engaged in the mathematical argument. They're engaged in the exploration of this relationship among those among the areas of those puzzle pieces. The fact that everybody was on task. There were no behavior problems, so I think that was pretty good. I think if there is one thing that I could improve on, I would have given them even more time to address I think that the most important part of the lesson, which is to focus on the two arrangements of the puzzles that they were able to come up, and really look at the relationships among those squares, because I think there are a few of them who are struggling with the concept struggling with the idea of the two smaller squares, the areas of the two smaller squares having an equal area to the larger square. So I think given enough time, they would have been able to really understand the relationship better.
You're done. Right?